So for today, we're starting with a whole bunch of really important information. Needs to be all put together to be able to find the x-intercept. You had to know that the x-intercept is where y equaled 0. So we put in a 0 there, and then we got this. And then we divided by -9, and we had to take a square root of a negative, which doesn't work. Yes?
That's actually what my question was about. If it doesn't specify that it needs to be a real solution, could you have like
Remember, an x-intercept is a real thing. So if you're saying, but my answers had imaginary things, well then imaginary things aren't x-intercepts. They aren't. They aren't there. It doesn't touch the x-axis.
But if it wasn't, if you weren't solving for an intercept, if you were just
There is
solving
such a
for
thing
an
as
intercept,
answers. Just I think you get what's going on here. There aren't any x-intercepts, right? Okay. And there are answers, but they aren't x-intercepts. Okay. All right, so the y-intercept is where x equals 0. So now I'm going to take and put 0 there, and I have 4y squared is equal to 36, because that whole piece dropped out when I put in x was equal to 0. And now that one can be solved. Y squared equals 9, and sadly, some of you still don't know that there's not 2 square roots of 9. The square root of 9 is just 3. So then some of you might be like, but there's going to be 2 answers. Yeah, because the square root of y squared is what?
Y.
No, it's not.
Absolute value.
Absolute value of y. Again, many of you were taught this incorrectly in the first time. This is going to come up on at least 3 tests this year. 3 separate tests this year. Out of 19 tests we'll have all year. You gotta know how to do this right. Because in one of your tests, you're going to end up with an answer that's like the square root of 16. And kids are like, so plus and minus 4. No, square root of 16 is 4. Okay, and the other thing is people won't know to make an absolute value when they square root a variable. All right, so don't be that kid. Know that it's absolute value. And now we can say that's why there's 2 answers. Y equals 3 and y equals -3. So there are 2 answers. I'm not saying there aren't 2 answers. I'm saying there's only 1 square root of 9. Okay. All right, now, what are these answers again? Are they x-intercepts? No, they were the y-intercepts. So if they're y-intercepts, it's what, comma, what? You'll have to list them as points. Y-intercepts are where what again? So 0, comma, and 0, comma, yeah. Can't draw 3 right now. There. Okay. Now, if we were graphing it, do you get to be pretty handy to have the knowledge that there was no x-intercepts, but there was 2 y-intercepts? Does that make sense? Okay. All right. Without any help from me, find the x-intercepts here and the y-intercepts. You saw me do it. Can you do it? I'll pause for a sec while you give that a try. 0 equals x to the 3rd minus x. And then I can see a lot of kids getting stuck right there, but I did give you my favorite saying, which is if you can factor it, you should. X comes out, you got x squared minus 1. If you're not good at that yet, you got to get good at that. Factoring's a big deal. It'll come up on this test multiple times. I warned you, and that's the reason it's my favorite saying is because it comes up all the time. X minus 1 and x plus 1 is how you factor that. You've got to know your factoring. It's right off the top 20. So if you're like, well, I didn't know how to factor that, then you didn't know the top 20. And I tried to show you. You'll need to know that. All right, so here is the key to the actual answers. Apparently there are 3 of them. 1 for this. What's that answer? X equals 0. What's that answer? X equals 1. And what's that answer? And if these really are x-intercepts, then their y is what? 0. So 0, comma 0, 1, comma 0, and -1, comma 0. Okay. Now let's do the y-intercepts. Nico, can you tell me what I do to find the y-intercepts?
You make the x 0.
Excellent. And so I now have y equals 0 to the third minus 0. What's that? Good. But what's the point? What comma what? If it's a y-intercept, then it's what? It's x equals 0. 0, 0. Oh my gosh, it's the same thing. Now, this is an important point. If you have found an x-intercept to be 0, 0, haven't you also found the y-intercept? Yeah, 0, 0 is both an x and a y-intercept. But, and this is important, some kids are like, there's no way there can be more than one y-intercept, so I don't need to look for any more. I kind of get that. Do you get if there is more than one y-intercept? You guys can't be chatting during this time. If there is more than one y-intercept, then you don't have a function. But we do things that aren't functions in here. You know what I mean? Like we do have things like that. That's a circle. We do those all the time. That's not a function. So don't think, well, it's impossible to have two y-intercepts because it can't be a function then. Well, we do non-functions all the time. Otherwise, you'd never have something with x-axis symmetry. See what I mean? There's something with x-axis symmetry. Not a function. But that doesn't mean it's illegal. Okay, so we're going to do those. So could you have something like, let's just move that whole thing over like this. Do you see how that has two y-intercepts? So yeah, sometimes you're going to have more than one y-intercept. All right, last thought is if I had to graph these, finding the x and the y-intercepts is a great start on graphing. But I want to just note for a second, if I just told you that I know a function and it's got these three x-intercepts, can you tell me what the rest of the graph looks like? You might assume that it's going to go like this, but could it also like go like that? There are functions that do that. Could it also, I mean, there's a million ways this could be looking. So we don't really know. But if I told you that I found a bunch more points and they looked like that, would you probably have an idea like what the function looks like? You put in enough dots, it becomes obvious. So how the heck are you going to get the other spots? I just showed you how to find x-intercepts and y-intercepts. How do you find other points? That goes back to a top 20. I know you're getting sick of hearing that, but it's true. If you don't know how to do this, if you can't tell me 3 spots on this equation, then you've missed one of the top 20s. And that's why you wouldn't be able to answer one of our test questions on Tuesday, is if you don't know how to find me 3 points on this. Well, I could find you the x-intercepts, Mr. Server. I put in y equals 0. And then, wait a minute, it doesn't factor. Oh dear. Okay, and maybe I could find you the y-intercept though, because that's x equals 0. Can anybody tell me the y-intercept? The y-intercept, if x is 0, see, what's y-intercept? 3. That's not that hard. But I could find a whole bunch of points on this. Right off the top 20. Find me 3 points on this. Do you get, you can just pick any number you want, stick it in, find a point. And if you get enough points, graphing is easy. Yes, sir. Yes. All right. I'm going to put in 1 and see what I get. And I have 1 plus 2 is 3 plus 3 is 6. Did you get 1 comma 6? Who has also figured that out? Okay, good. And if you put in x is 0, we got 3. You already did that. And then let's do one more point. Let's put in -1. If I put in a -1, it's like there's parentheses around this, which does matter, because -1 without a parentheses squared is different than with it. So those parentheses matter. So that's -1 times -1, which is 1, plus -2, which makes -1 plus 3 is 2. Raise your hand if you had -1 comma 2. Good. Do you get how I could get a whole bunch of points? Anybody can graph once they have like 16 points. Some kids on the test are going to figure out the x or the y-intercepts, and then they're going to not know how to find any other points. If you can find a few other points like that, now you'll be like, well, duh, it goes like that. That's easy. So find more points. Makes it easier to graph. Okay, enough about that. So today's got 2 parts. One is finding x's and y-intercepts and other points. on a graph. And then there's talking more about symmetry graphically and analytically. Graphically is easy. If I just say, here, look at this, what kind of symmetry does it have? Y-axis, because it goes over that. Does that make sense to you? That's y-axis symmetry? All right. Does it also have x-axis symmetry? No. There are some shapes that have all three kinds of symmetry. So just think about this one carefully. Would this have all... I didn't draw it perfectly. Assume I did. It's an oval. It's kind of like stretched out over this origin there. Would it have x-axis symmetry? Yes. Would it have y-axis symmetry? Yes. Would it have origin symmetry? Yes. And again, I know it's bent, but if I go from here through the origin down here, there'd be a spot. Like, let's say this was the spot 2, 6, then the spot -2, -6 would be there. So that shows me the origin symmetry part. The part that shows me x-axis symmetry is that straight through here, there's another point, which would be 2, -6. And the part that shows me y-axis symmetry is that over there, there would have been a spot -2, 6. Do you get if it has x-axis symmetry? Here's the x-axis. If it has x-axis symmetry, then the x stayed the same. If it had y-axis symmetry, the y stayed the same. And if it has origin symmetry, they're both the opposite of what they were. If you understood what I just said, it leads really well into the next slide. Just a quick reminder, you should be asking 10 people about your Venn diagram lab. It's not due till Wednesday of next week after your test, but I strongly recommend asking kids in class in the last 10 minutes because they all have the same lab as you. Easy 10 people to find and ask. All right. So we're going to just show how you would test for x-axis symmetry. You should write these somewhere where you can find them. Because right before your next test, this would be the kind of thing to power memorize. Like right before the test, you're going to be asked to prove something as x-axis symmetry. So you're going to leave the x the same and make the y the opposite. You're going to test for y-axis symmetry by leaving the y the same, make the x the opposite, and you're going to test for origin symmetry by making them both opposite. So what are you talking about, sir? Well, I'm going to give you this. I can test and see if it has x-axis symmetry by sticking in regular x and opposite y. So here I put opposite y. Here I put in regular x, which, is already there. And I ask myself, does this simplify down to the exact same thing as it was before? I wish I hadn't written over it now, so I'm going to rewrite it here. Y equals x to the third minus x was the original. Will this simplify to the exact same thing? We'll solve it for y, and you end up with negative x to the third plus x. Clearly, that is not exactly the same as that, is it? Then it doesn't have that kind of symmetry. We were testing it for x-axis symmetry. Now I'm going to test it for y-axis symmetry, so I'm going to stick in negative x and y. So it was y equaled x to the third minus x. I'm going to stick in negative x. And if I'm testing for y-axis symmetry, I leave the y alone. Will this simplify to be the exact same thing as it was before? Y equals, well, do you know that negative x to the third will be negative x to the third plus x? Is that the same exact thing I started with? No. Here's what I started with right there. That is not exactly the same. So it doesn't have y-axis symmetry. What kind of symmetry do you think it probably has then? Origin. No, we just checked x and it didn't have x, didn't have y. It's probably got origin. So would everybody please write exactly this. Y equals x to the third minus x. That's what you start with. And then stick in a negative x and a negative y underneath that. and simplify it all down, and you'll see. Need to do this. Finger hasn't moved. Tell you haven't done it. You'll see that it simplifies down, and we assumed it probably had y-axis symmetry in, and it does. Stella, what did you put in for y?
I couldn't even find out which one.
Right here.
Negative y.
So what did you put in for y? Negative y. What did you put in for x?
Negative x.
Yep. Mariam, negative y is equal to, you need to simplify this for me. I agree, this is positive x, and then what's the first part though? This part? Yep, there you go. Now, is this solved for y yet? No, that's the last step, so I gotta solve for y. So I'm dividing everything by a negative. I'd be fine with you doing that in your head. The opposite of x to the third is x to the third. The opposite of plus x is minus x. And look at that. It's the exact same thing as we started with. So when we put in a negative x and a negative y, we get the exact same thing we started with. All right. That proves that that function has, or actually it isn't even a function. No, wait, it is a function, my bad. Doesn't matter if it's a function or not. If I start with any equation, I can tell whether it's got origin symmetry by sticking in negative x and negative y. All right, so I'm going to give you a really simple one. Would you agree that y equals x squared is much simpler than what we just did?
Yeah.
Do you know already which kind of symmetry it has? I do, because I know what it looks like. When you think about what it looks like, what kind of symmetry does it have? Y-axis symmetry. Now prove it. Not by graphing it, by doing that little thing with the negatives and the x's and the y's. Prove that it has y-axis symmetry. So Nick Voves, how do you prove it has y-axis symmetry? Yeah, leave the y alone, but you make the x negative. So if you want to prove y-axis symmetry, you leave the y alone. And then if I actually do that and I have negative x squared, it's x squared. Look at that, same as the original. What'd I prove? Y-axis symmetry. That's how you prove something as y-axis symmetry. All right, I'd like you to try this without my help. Y equals x to the third. Prove that it doesn't have some kinds of symmetry, but it does have another. Check it for x-axis symmetry, check it for y-axis symmetry, and check it for origin symmetry. Here's me checking it for x-axis symmetry. You leave the x the same. You change to negative y. So, negative y is equal to leave the x the same. I solve it down. Positive y equals negative x to the third. That is not the same as that. So it does not have x-axis symmetry. I'm going to skip right to the ending. I tested for y-axis symmetry in my head by sticking in negative y-axis symmetry. I leave the y alone, stick in a negative x, and it comes out to negative x to the third, which is not the same as x to the third. So now I'm going to test for the one that I know actually works, which is origin symmetry. Not motivated today.
No, I didn't.
You checked all three?
Yeah.
Wow, you have really fast hands. I'm going to come and look at it in a second because I'm having a hard time believing it. Origin symmetry, negative x comma negative y. And I have got negative y equals negative x to the third. And I simplify it down and I have y equals negative x to the third. Is that the same thing I had in the first place? What went wrong? That's supposed to have origin symmetry.
Yeah, that when you divide by -1, you forgot to do the intercepts.
Ah, I should have. I didn't show my work. Look at that. You're absolutely right. That was what I did. Now, that could easily happen on a test, couldn't it? You just like, I just didn't show my work. And all of a sudden, I was thinking that it wasn't having origin symmetry. Well, the bad thing on the test is you're never going to be able to look at the equation we give you and go, oh, I know it's got origin symmetry ahead of time. You're going to have to use this process. And so you wouldn't have been able to catch that. You would have just thought, nope, it's not the same as the original. Doesn't have origin symmetry, but it actually did. And you made a mistake in the work. All right, so just be really careful. This is the one kids get wrong a lot on the test because there's so many negatives and so many chances to mess up. So if I give you a question, this is not right now, but if I did, if I gave you that, anybody in here know what kind of symmetry it has just by looking at it? Nope. But would you know how to test it? Good. That's the point. All right. This one, they want you to test it graphically. That means you'd actually graph it. And it turns out to be an oval. That's why they put that weird looking plate in there. So if it's an oval, what kind of symmetries would you think it probably has? Probably has all three. All right. What if you were asked to find the x-intercepts of it? Do you think you could do it? Yeah, just put in y equals 0. What about the y-intercepts? Let's put in x equals 0. What are these sample points? XY chart. I want you to just give me 2 sample points that aren't x or y intercepts. Like stick in x is 1 and then figure out what y has to be. Or stick in x is 2 and figure out what y has to be.
You said 2 sample points?
2, just 2. Typically on a test, if you get the x-intercepts and the y-intercepts, if you have a couple more points, you'll be fine. Gwen, tell me how to do this. I want to find a sample point. Okay, so put a 1 here. And then, do you know what to put in for y? No, that's kind of the point. You got to like solve it. So what do I do? Okay, so what's this? 4. So I'm going to subtract 4 from both sides. And then I got 2y squared equals what? And then what? Y squared equals 14. Yuck. You mean that I'm going to have an answer like the square root of 14? And there isn't just the square root of 14. When you square root this, you get 2 answers. Square root of 14 and the opposite of that. Why? Because of this. Remember me saying it was beyond 3 separate tests this year where you could get burned out on that? It's plus and minus. And I'm not going to put it right there because that implies the square root of 14 is 2 things. Square root of 14 is just a square root of 14. But that splits into 2 things. And y would be the square root of 14. And y would be negative the square root of 14. I got my 2 answers. And that was 1 x value gave me 2 separate y values, but that's 2 points that are on this graph. And now some kids were like, how the heck are you supposed to graph the square root of 14? Would you agree that that's kind of close to the square root of 16? What's the square root of 16? 4. Do you get this as a little less than 4 then? So on a graph, I just expect you to put a dot that's a little less than 4. Yes?
So you said that you won't put the absolute value, plus or minus symbol for square root of 14.
It's okay at the end if you want to do this, but the problem with this is kids don't even recognize that that's two separate points on the graph. You know what I mean? We put in x was, what did we put in, 1? We put in x equals 1, and then they think I got one answer and it's the square root of 14, and oh yeah, it's plus minus. No, you actually have two answers, one with the square root of 14 and one with the negative square root of 14. So it just helps you to separate them into two distinct things. You can write plus and minus there, but here, you'd want them as two separate points. There, we found 2 points on the graph. And I said that square root of 14 would be just a little less than the square root of 16, so it would be a little less than 4. Okay, good. That's it. You now know everything that you'd need to get a good grade on the test. But you have tonight to practice these things, and then this weekend, okay? And then Monday we'll do a practice of everything. I'll remind you of everything we did since the beginning of the chapter. Okay, but this stuff that takes a long time, that's the hardest stuff. And you might be like, well, I got everything except that last day. If you don't understand today, the best you can have on the test is a B. You need to understand today. Okay, and it wasn't impossible. One part of it was finding points and the x and y intercepts. The other part was knowing what the heck this means. If I put this in an equation, that tells me whether it's got origin symmetry or not. Don't you? I would if I were you. Pay attention because they're important. Pay attention. This page is part of your homework. That is very typical right off what we're going to test you on. I would definitely do that. You want to know which problems. This, we already did this one, so you don't need to do that one. Just wait. And this is very important. I would do the pink page, and you might be like, we already did it. We did some of it. You need to do the graphing of it, especially. All right, that's all I got for you for today. Have a great day.
Thank you.
Yep, take care. This would be extra. You don't have to do it, but it wouldn't hurt you.
Thank you.
Have a great day.
You too.